So you've already learned some things in math or mean the same thing even though they look different. So for example, in fractions, 12 out of 20 is the same as 3 out of 5. And we would say 3 out of 5 is lowest terms. That was technically better than 12 out of 20 as far as writing your answer, right? If the answer was 1, you would like to write it as 1. You wouldn't leave it as 4 divided by 4, even though they mean the same thing. Okay? Now, in square roots, and there's some history behind this, and the history behind this is that before calculators, it was quite difficult to find a square root, but wasn't that bad. Like, you could do a method to find as many decimal places as possible with a square root. And it would go on like square root of 2 is 1.41 dot, 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 and continues on forever. It was, however, very difficult to divide by a square root. It would take a long time because of all those decimal places. So there is a technique that was used so that the bottom was never a square root. And that technique is fairly simple, is saying, well, what would I multiply the square root of 2 by so it's no longer a square root? Well, if I multiplied by another square root of 2, then that will equal just square root of 4, which is just 2. But I can't just multiply the bottom of the fraction by something. I also have to, just like when changing fractions to get a common denominator, what you multiply on the bottom, you multiply by the top. Technically, if I multiply by the square root of 2 over the square root of 2, I'm multiplying by 1, just a fancy looking 1. And I'm just changing what the fraction looks like, not what the fraction is equal to. So now when I multiply the bottoms, I'm going to get root 2 times root 2. That's just going to be root 4, which is 2. And the top is going to be root 2. And before the advent of calendars, it was not hard. Like I said, you could find the square root of 2, and you get 1.41. And dividing by a whole number wasn't bad, even if the decimal places went on forever. Like you can probably even imagine, if I have 1.41, I divide by 2, I'm going to get like 0.705. Mental math, that wasn't even too bad. But if I tried to do 1 divided by 1.41 dot, 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 that would take some time. So this is a bit historical in that this was a very important technique before the advent of calculators. Technically today, you can type 1 divided by square root of 2 into your calculator. You can type the square root of 2 over 2 into your calculator and get an answer just as fast either way. Okay? But we still have this idea present in math that we always want to have the denominator be a whole number, and we call this rationalizing the denominator, which I was going to highlight, but not anymore, because it's not responding. Does this work? No, that made it matter. I wanted to highlight that definition called rationalizing the denominator. So the idea is, while we're waiting for this to go away, there's always going to be something that you can multiply the bottom by to get rid of the square root. In this case, I had square root of 2 on the bottom. I multiply by square root of 2 to get rid of it. If I had the square root of 5 on the bottom, can you see that you'd multiply by square root of 5 to get rid of it? Because then whenever you have a square root times a square root and the same numbers inside, square root of 7 times square root of 7, I mean, you could take the extra step to do square root of 49 and then go, that's going to be 7. Yes. Okay? So this is, the simplified form. We'll just underline that. So we're adding to the complexity of the definition of the word simplify in math. Simplify in math is complicated because for fractions, you have to have lowest terms. Now you've added, for radicals, simplified means write as a mixed radical. And now for radicals, it means write as a mixed radical and better not have a square root on the bottom, because then it's not simplified. So that's what we have in example 3. We have a bunch of questions where there is a square root on the bottom. So we need to get rid of that square root on the bottom. And we ask ourselves, well, in A, what could I multiply the bottom by to get rid of the square root? I'd have to multiply by the square root of 7. And what would I then multiply the top by? I'd also have to multiply the top by square root of 7, so I don't change my answer because what I wrote in blue is equal to 1. I'm not changing my answer, I'm just changing what my fraction looks like. Now on the top, you had two things, so you're going to have to distribute. And on the top, you'd have 5 root 7 times root 7. Well, it'd be 5 times 1, which is 5. Root 7 times root 7, which is root 49. Plus, and then 3 times 1 is 3. And then you have root 7 times no square root, so it's still root 7. And on the bottom, root 7 times root 7. You could write root 49, but you're going to get pretty quick at being able to just write 7. Can you see that you could have just written 7 for the 49 here, and that's fine. Right now I'm taking it slow. I'm doing the steps so that we can see where it's going. But yes, the top is going to be 5 times 7 plus 3 root 7 divided by 7. And do we have any like radicals on the top? No, so I can't combine these. This is our simplified answer. Now I'm going to do B in 2 different ways. Okay? I'm going to do B first the way I think you would do it based on what you saw so far. Based on what you saw so far, we have a square root of 18 on the bottom. Okay? So I'm going to get rid of that square root of 18 by multiplying by square root of 18 and square root of 18. Can you see yourself doing that as the method that you would do based on what we did in part A? Perfect. So then I have to distribute. I would get 6 square root of 36 minus 4 square root of 54. And the bottom's just going to be 18, because square root of 18 times square root of 18 is just 18. Then I have to look, can I simplify anything else? Well, the square root of 36 is just 6. So this will be 6 times 6, which will become 36. And 54, can you see that 54 is 9 times 6? And square root of 9 then would be 3. So since 54 is the square root of 9 times the square root of 6, and square root of 9 is 3, the top becomes that. That's still over 18. So now I have 36 minus 12 root 6 over 18. Are we done? Unfortunately not. Because in lowest terms and fractions, if there's something in common between the 36, the 12, and the 8, you can reduce it. Is there a number that divides 36, 18, and 12? 6? You could have also seen 2, right? But 6 is bigger. We want to take the biggest one possible. So the number that divides all of them is 6. So if we divide each of them by 6, and sometimes this is shown by saying first factor out, oh no, first factor out a 6 out of the top. And then you can reduce that to 1/3. But some people are like, oh, there's 6 in each of them. I'm going to divide this by 6, this by 6, this by 6. And what am I left with? I'm left with 6 minus 2 root 6 over 3. And so you have to know how to simplify regular fractions, what we just did there, finding a common factor and dividing them all by that. That's from previous years, grade 9 and grade 10. But now we've added the radical simplification in there as well. Now, I said I was going to do this in a second way, so I'm going to start the question over again in black. The original question was 6 root 2 minus 4 root 3 over root 18. And the way that I'm going to do it this second time is the second time I'm going to look at this and say, hey, root 18 could have been simplified. What if I saw that first? Root 18 is root 9 times root 2. So it's 3 root 2 for writing it. If I did that first, if I decided to simplify the square root of 18 first, now to get rid of the square root, I don't need to multiply by root 18. All I need to multiply by is a root 2. So I multiply by root 2 on the top and the bottom. What do I get? I get 6 times, and are you okay this time that root 2 times root 2, I'm just going to write it as 2 instead of root 4 to save ourselves a half a step. Minus 4 root 6, and on the bottom I would have 3, and then root 2 times root 2, that's just 2. So I have 12 minus 4 root 6 divided by 6. You've got 2 terms on the top and 1 on the bottom. Is there a number that divides all 3 of them? You can divide all 3 of them by 2. So if I divide that by 2, I get 6. This by 2. This by 2. And we get the same number, but we didn't have to have as big of numbers, right? Like the other example, I got all the way up to square root of 54, which isn't crazy, but these numbers are a little bit smaller. And usually, if you're working with smaller numbers, that means that your mathematics is a little bit easier. Okay, so we're going to leave example 4 for tomorrow because it's the next level of difficulty. We're going to do number 6, 9, 13i and II, and 14, and we're going to work on those right now to practice this.